Hey guys, I'm going to be doing number 6 from the homework tonight. So the instructions are to evaluate this. What we have is a trig function here, but we've got an angle that's much greater than 90 degrees. So we don't have a triangle we can use, which means we're going to have to create one. So what I usually do first is make our invisible coordinate plane here so that we can kind of orient ourselves. And we have to kind of pretend that there's a unit circle around this space. What that does for us is gives us a radius of 1. Now the next thing that we're going to do is we're going to figure out where 315 degrees would be. If I've got a line that's extended and this is 0 degrees and we go all the way around with it, dragging the end point of that line, which has a radius of 1, to about here, that would be 315 degrees, because this line here, if the angle only came to the y-axis in the negative space, that would be 270 degrees. All the way back around would be 360 degrees. We're right smack dab in the middle of that. So we're going to create a right triangle just like we always do. Go back to the x-axis with it with a right angle. All right. Now what we have to figure out is if this is 315 degrees here, what is our reference angle? And the way that I'm going to figure that one out is I'm going to say, well, the reference angle looks like it finishes the unit circle. So if a circle is 360 degrees, and this is 315 of them, let's do 360 minus 315. So that angle is going to be 45 degrees, which means this angle would be 45 degrees, which means we've got a 45, 45, 90 triangle with a radius of 1. So the first thing that we have to figure out, what is this leg and what is this leg? Because we know that most 45, 45, 90 triangles have a 1 to 1 to radical 2 ratio. Well, they all have that ratio, but our special right triangle that has those degree measures has these side lengths. So one of those just became a 1, and the way that that happens is by dividing by radical 2. So we have to do that to the other two sides as well. And we'll end up with 1 over radical 2, but we can't leave it this way. These have to be adjusted. Remember, 1 over radical 2 has a radical in the denominator, so in order to get rid of that, we're going to multiply it by radical 2 over radical 2, which is really just a 1, so it won't change the value, but it will change how it looks. So we have a radical 2 over 2 now. So now each of these sides have a length of radical 2 over 2. Which is useful because now instead of evaluating cosecant of 315, we can evaluate cosecant of 45. And since we know that cosecant is the inverse function of sine, and sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite, which in this case is going to be 1 over radical 2 over 2. Which is the same as 2 over radical 2, and we can't leave it like that. So you'll get 2 radical 2 over 2, those cancel. So cosecant of 45 is radical 2, and the last thing we have to check for is which quadrant are we in, and is our trig function positive in that quadrant? In quadrant 1, all of them are positive. Quadrant 2, just sine and its reciprocal function cosecant are positive. In quadrant 3, just tangent and its reciprocal cotangent are positive. And in quadrant 4, which is where we are, it's only cosine and its reciprocal function secant that are positive. So in this case, we have a negative radical 2 because we are not in quadrant 2, and that's where we would have to be if cosecant were going to be positive. All right, the rest of them are just like this. Good luck, you guys. I'll see you tomorrow.